and up to 6 months or longer if they are breastfeeding exclusively. This is significant because uninterrupted menstrual cycles, as in never getting pregnant, means nonstop exposure to ovarian hormonal fluctuations, which stimulate cell growth in the breasts, ovaries, and endometrium. To a lesser extent, this is also true of women who have their first child late in life, or never have a child. A woman who has her first child at age 40 or later has a 4-fold greater risk of developing breast cancer compared to a woman who has a child at age 15, largely because the older women have gone decades without getting an extended holiday from hormonal stimulation. In a 2019 study involving more than 64,000 women who were diagnosed with or tested or treated for infertility, and more than 3 million women who were seen for routine gynecological care, researchers from Stanford University sought to investigate whether similar risks apply to other cancers by tracking the women's health over several years. It turned out that the women who were seen for infertility testing and treatment had an 18% higher risk of developing uterine, ovarian, thyroid, liver, and pancreatic cancers, as well as leukemia. Interestingly, among the women who were classified as infertile yet became pregnant and gave birth to a child during the follow-up period, the risks of uterine and ovarian cancers dropped down to match those of their naturally fertile counterparts. In addition, the lifestyle and chemical-related stressors that can alter a man's or woman's reproductive health can also modify the expression of his or her genetic code and possibly affect future generations of their families. Tinkering with the master plan. How might these hand-me-down effects work? That's the domain of a field called epigenetics, which literally means on top of genetics. The term, coined by British scientist Conrad Waddington in 1942, refers to the study of biological mechanisms that can change gene function and expression, for example, by switching particular genes on and off, or dialing their expression up or down, without altering the underlying sequence of DNA. In the span of several decades, the field has blossomed and provided new insights into how a person's environment, including his or her exposure to certain chemicals and lifestyle practices, can influence the expression of certain genes, which can then alter his or her risk of developing specific health conditions. Here's where things get complicated. Some scientists use the word epigenetics to refer to chemical or physical changes that affect gene regulation without altering the essential DNA sequence. By contrast, others believe the term should apply only to changes that are heritable, meaning passed from one cell to another or from one organism to another. If you're finding it difficult to wrap your mind around all this, you're in good company. As Siddhartha Mukherjee, MD, noted in The Gene, An Intimate History, the shifting meaning of the word epigenetics has created enormous confusion within the field. Here's the gist of what you need to know. Your genes and your environment can interact in ways that can change how your genes are used or expressed. That alone is amazing enough, but here's the really astounding part. The food we eat, the air we breathe, the products we use, and the emotions we feel have the potential to influence not only how our genes are expressed, but also how those of our unborn descendants might behave in the future. That's right. Our lifestyles and environments can have ripple effects on the health and development of our unborn children and grandchildren through mechanisms that foster cellular memory and can be maintained across several generations. Such effects are considered transgenerational when they're seen in a generation that was not directly exposed to the stimulus in question, such as the sons and daughters of a parent who was exposed. When the effects extend to the second, third, or fourth generation after the generation that had the initial exposure, then they're deemed to be multi-generational. Together, these passed-along influences can be considered intergenerational, an all-encompassing term I prefer for simplicity's sake. An analogy. Imagine that a documentary was being made about the development and maturation of your body. The genes you carry would provide the script, outlining key actions or events that would be featured in the film. Epigenetic changes would reflect alterations or tweaks a director might make to how the script is performed. In this case, by causing certain sets of genes to be turned on, expressed, or turned off, inhibited, or silenced. In other words, the director, epigenetic changes, has the power to yell, action, or cut, or to suggest putting a different spin on a particular event. In real life, epigenetic changes, which are part of the normal development, health, and survival of the species, can influence a person's risk of disease throughout the lifespan. When someone is exposed to a particular stimulus, whether it's a toxic chemical, intense stress, or a certain dietary factor, this influence can elicit epigenetic modifications that can have lasting effects on the person's development, metabolism, and health, and sometimes even the development and health of that person's offspring. We know of 3 primary epigenetic mechanisms, which I'll explain here, and others will probably be identified down the road. One of the best characterized is DNA methylation, a chemical process that adds a methyl group, a common structural unit of organic compounds, to DNA. DNA methylation, which helps regulate major cellular processes, essentially acts like a switch that dials the activity of genes up or down by modifying a gene's interactions with the machinery within a cell's nucleus. In another epigenetic mechanism, histones, which are proteins that serve as a spool around which DNA is wrapped, can be modified through specific chemical processes. A particular histone modification can then precisely calibrate gene expression. A third epigenetic mechanism involves RNA, short for ribonucleic acid, which is present in all living cells and plays essential roles in the coding, regulation, and expression of genes. The RNA silencing mechanism is a modification during which the expression of one or more genes is downregulated or suppressed by small non-coding stretches of RNA. Without getting into the weeds on non-coding RNA function, suffice it to say that these RNA molecules can alter gene expression and play a key role in biological processes. One way or another, all of these epigenetic mechanisms act as switches, modulators, or tags, which serve as a kind of cellular memory that can change the epigenetic landscape. These changes are akin to editing and rewriting the script for your life story. Now imagine that someone is using different colored highlighters to mark up different parts of that script, to indicate which parts need to be read most carefully, say orange, and which ones aren't as important, say blue. The color coding system can change throughout your lifetime in response to environmental influences, so that a part that was once blue becomes orange or vice versa. In addition, some lines or stage directions can be passed down to your next of kin, just as some highlighted portions of a document still show up as either a color or a shade when it is photocopied. This is the essence of how epigenetics works. Undesirable legacies. Your life story may not stop with you, however, and that may be the most astounding part. These epigenetic effects can influence a child's risk of developing asthma or allergies, obesity, heart or kidney disease, some neurological disorders, and some reproductive abnormalities. It has long been recognized that there's an intergenerational transmission from mothers to children of exposure to chemicals, metals, pharmaceuticals, stress and trauma, and other detrimental factors, which makes sense intuitively since a mother's body is a baby's first home. Increasingly, research is suggesting that the same is true of men. Here's one area where this has been illustrated. A parent's experience with war, trauma, or severe stress can have hand-me-down effects on the mental health of his or her offspring, even if the children don't grow up hearing stories of these horrors. The descendants of trauma survivors seem to inherit a biological memory of the hardship their parents endured, namely, through alterations in certain genes and levels of circulating stress hormones, according to Rachel Yehuda, PhD, a professor of psychiatry and neuroscience at the Icahn School of Medicine at Mount Sinai. In one study, Yehuda and her colleagues interviewed adults with at least one parent who was a Holocaust survivor and adults whose parents hadn't been exposed to the Holocaust or experienced post-traumatic stress disorder, PTSD. Then, they took blood samples from the participants to compare methylation of a gene that's involved in the stress response, GR1F, and cortisol levels in response to being given low-dose dexamethasone, an anti-inflammatory drug. They found that subjects whose parents had experienced PTSD had alterations in methylation of this particular gene, a sign of trauma-induced epigenetic modifications. This may sound like a lot of technical gobbledygook, but these alterations can have significant consequences for later generations. Another of Yehuda's studies, including Holocaust offspring, found that a mother's PTSD significantly enhanced her child's risk for developing PTSD, while a father's PTSD significantly elevated his son's or daughter's risk for depression. Whether these effects are ultimately due to the parent's unpredictable behavior or epigenetic changes in a father's sperm has yet to be determined. But the idea that traumatic experiences can affect DNA in ways that are transmitted to subsequent generations, like molecular scars, is an upsetting family legacy. On the male side of the family tree, research involving mice found that the offspring of males who had significant stress before breeding displayed substantial alterations in stress reactivity of the hypothalamus-pituitary-adrenal HPA axis, which controls a person's or animal's response to stress, in this case, due to epigenetic reprogramming. This is especially noteworthy because altered stress reactivity is a prominent feature of PTSD, so it seems that a father's prior PTSD can become his child's PTSD through inherited molecular mechanisms. Taken together, these studies lend credence to the theory that psychological trauma, or extreme stress, can induce epigenetic changes that can be passed down from either parent or both and have real-life consequences for their children. The multi-generational digestive tract. Another example of the intergenerational transmission of health effects, large fluctuations in the availability of food, from too little to plenty or the other way around, during grandparents' early years can have surprising trickle-down effects on subsequent generations. Research from Sweden found that if a paternal grandmother experienced drastic changes in her access to food from one year to the next up until puberty, her son's daughters, her granddaughters, had a 2.5 times higher risk of dying from cardiovascular disease as an adult. Similarly, babies exposed to nutritional deficiencies while in the womb during a severe famine in the Netherlands, known as the Dutch famine or hunger winter of 1944 to 45, were found to be at increased risk of becoming obese and of developing schizophrenia as adults. By contrast, women who were children ages 2 to 6 and experienced severe hunger during the Dutch famine have been found to experience natural menopause earlier, compared to their peers who weren't exposed to the famine. Dads aren't off the hook when it comes to diet. Studies have found that children conceived by undernourished fathers were heavier and in some instances more obese than children born to fathers and mothers who were well-nourished before conception. By age 9, the sons of fathers who started smoking before age 11 have a higher risk of becoming overweight or obese. Interestingly, while the sons of fathers who took up the smoking habit at an early age have a higher body mass index, the same isn't true of the father's daughters. Another body of research in male mice suggests that the sons of fathers who have a folic acid deficiency, or who have the highest dose of folic acid supplementation have lower sperm counts. In other words, on the dad's side of the equation, there's no question that these paternal lineage effects are transmitted via sperm. Parental advisories. Unsurprisingly, given all this, the lifestyle factors and environmental chemicals that a man or woman is exposed to can have reverberating effects on the reproductive health of generations to come. None of these potential epigenetic influences have slam-dunk effects, however. They don't occur in every single child who is born to parents who've experienced particular exposures that can induce epigenetic changes. But they can theoretically occur in any given child, and exposures in past generations make it more likely that these changes will happen. That said, when these epigenetic changes do occur, just how many generations are affected by these exposures remains a matter of ongoing debate and research. It isn't clear, for example, whether the damaging effects of a particular exposure are perpetuated in both male and female children, as well as third or fourth generations of descendants. The answer seems to depend on the culprit in question. As an example, let's take a look at DES, which you'll recall was prescribed to millions of pregnant women until the 1970s because it was believed to prevent miscarriages. First of all, the treatment didn't prevent miscarriages. In fact, it increased the risk. Worse, it increased the incidence of certain reproductive disorders in the male and female offspring who were exposed to the drug in the womb. Most of the research on prenatal exposure to DES has focused on the reproductive effects in girls and women, and there are plenty, as you've seen. Less well known are the potential effects in the boys and men whose mothers took DES during pregnancy, and these are significant. Not only can in utero exposure to DES increase the male baby's risk of having undescended testicles, hypospadias, misplaced urethral openings, epididymal cysts, and infection or inflammation of the testicles, but these boys also have higher chances of having micropenises, abnormally small but normally structured penises. Whether there's also an association with decreased sperm counts or testicular cancer isn't clear because research on the effects of DES in sons hasn't been extensive. The real surprise. Some evidence suggests that the sons of females who were exposed to DES while in the womb, the grandsons of the expectant mothers who were exposed to DES, have an increased incidence of two genital abnormalities: undescended testicles, and an abnormally small penis. In these instances, the DES damage can trickle down 2 or 3 generations, an effect that could be the result of epigenetic changes that are transmitted to subsequent generations through men. Here's an example of how these effects can unfold with current chemical exposures and reproductive development. In a 2017 study, researchers examined phthalate levels in the urine of men undergoing in vitro fertilization, IVF, and found that several of these phthalates were associated with changes in sperm DNA through what's called DNA methylation that resulted in poorer embryo quality and a lower chance of successful implantation. The phthalates affected the genes that can influence a male baby's reproductive development and eventually a grown man's semen quality and fertility status, that is to say, whether or not he can have children. There's also evidence that a male's exposure to endocrine-disrupting chemicals can travel farther down the family tree, affecting reproductive development in successive generations of males. On the female side, research also has found that exposure to environmental toxins can lead to the intergenerational inheritance of PCOS, or a premature reduction in the pool of viable eggs, aka diminished ovarian reserve. Unfortunately, it gets worse because it appears that given the increasing number and volume of endocrine-disrupting chemicals and other toxins in our world, the damaging effects could be additive over time in descendants of the originally exposed person. In studies involving male mice, researchers at Washington State University sought to investigate the potential for this augmenting effect. So they tested the cumulative effects of the male mouse's prenatal and then his postnatal exposure to estrogenic chemicals, not just in one generation, but also in 3 successive generations, and compared the severity of the effects across the various generations. They found that exposure to the endocrine-disrupting chemicals affected both the reproductive tract development and sperm production in the male mice that were exposed. No surprise there. More startling was the finding that when subsequent generations were exposed to these endocrine-disrupting chemicals, the effects of the originally reported changes in sperm-producing cells were amplified. In addition, the incidence and severity of reproductive tract abnormalities, such as kinking or collapse of the vas deferens, which conveys sperm from the testicles to the urethra, and testicular fibrosis, which can lead to male infertility, were increasingly observed, suggesting an additive effect. The impacts were worse in the second generation compared to the first generation, and worse still in the third. That the damage got worse and worse as more generations were exposed suggests that male sensitivity to environmental estrogens is increased in successive generations that are exposed to common endocrine-disrupting chemicals, leading to a progressive decrease in sperm counts over multiple generations, a phenomenon that environmental scientist Pete Myers refers to as a male fertility death spiral. This may sound like nothing more than a doomsday-themed video game or movie, but the possibility that the damage is getting worse and worse as subsequent generations are exposed to EDCs is beyond frightening. Where will the harm end? Revising our reproductive programs. Epigenetic and intergenerational effects such as these are significant and worrisome for humans and animals alike. After all, the evidence suggests that once these changes occur, the revised program for the future development of cells and body systems in successive generations could become permanent. It's as if the new pattern becomes etched in stone and cannot be altered or erased for either that particular man or possibly his future male heirs. These findings shed light on the big revelation of my own research: that male sensitivity to environmental hormones is increased in successive generations of exposure, from a father to a son to a grandson, might explain the continued decline in sperm counts we saw over subsequent generations. As these second, third, and fourth generation relatives are subjected to these harmful environmental influences, they become more sensitive to their effects, and there could be inherited DNA damage as well, which is yet another additive factor that can create a vicious cycle. Where in a family's lineage these damaging effects will stop, nobody knows. There is, however, a glimmer of hope that some epigenetic effects may be reversible. For example, it's theoretically plausible that the propensity to become obese could be altered by changing the environment in the womb and the person's lifestyle in adulthood. Research in mice found that dietary supplementation with folic acid or genistein during pregnancy negates DNA hypomethylation and can counteract the damaging effects on the unborn pup of exposure to bisphenol A, an industrial chemical that's used to harden plastic. Think baby bottles. That's the biological equivalent of clicking the undo function on your computer and erasing the error you just made. But it isn't yet known to what extent future generations of human beings could be rescued from undesirable epigenetic changes, or which effects are potentially reversible. Whether someone is lucky enough to escape this epigenetic cascade of unwanted intergenerational influences appears to be a matter of chance. Reproductive abnormalities, fertility challenges, and a higher risk of chronic diseases aren't acquired traits that any parent wants to pass along to his or her children. But our modern world has made it increasingly difficult to avoid these risks. That's why scientists from around the world are issuing calls to action, such as protecting the food supply and reducing exposure to chemical cocktails in the environment, to protect the fertility and reproductive health of future generations. 9. Imperiling the planet. It's not just about humans. Soiling our nests. In the North Pacific Ocean lies an enormous trash vortex, a convergence of more than 87,000 tons of floating debris, including plastic particles, chemical sludge, and other fragments of litter. This massive detritus has come to be known as the Great Pacific Garbage Patch. Rather than being a discrete mass like an island, this swirling maelstrom of refuse is more like a diffuse galaxy of garbage that has grown to be about twice the size of Texas. It poses a danger to wildlife since the debris often ends up in creatures' stomachs or wrapped around their necks. Of the 1.5 million albatross that inhabit Midway Atoll near the garbage patch, the vast majority have plastic particles in their digestive systems, and approximately 1/3 of their chicks die. The floating debris absorbs organic pollutants in the seawater. Then fish and other marine life consume these toxin-containing pieces of plastic. When humans eat these fish, we ingest microparticles of these toxic chemicals, another harmful trickle-down effect in our ecosystem. This is hardly an isolated occurrence. There's also a tide of plastic waste along what was once the idyllic coastline of the tiny Honduran island Roatan, as well as a nearby series of trash islands composed of garbage, particularly styrofoam and plastic, along with seaweed. In 2017, a floating mass of tiny plastic pieces larger than Mexico was discovered in the South Pacific. Meanwhile, in the Atlantic Ocean, extreme concentrations of microplastic pollution have been found in the Sargasso Sea. And in 2019, researchers spotted a floating mass of plastic waste, dozens of miles long, between the islands of Corsica and Elba in the Mediterranean Sea. In each of these locations, sea creatures are literally swimming in trash and plastic chemical soups of one kind or another. The United Nations Ocean Conference estimated that the oceans may contain more weight in plastics than fish by the year 2050. Intentionally or not, human beings are treating the planet's oceans like a garbage dump. The debris-strewn oceans aren't the only casualties of our throwaway society, and these masses of detritus aren't just unsightly. They're also harmful to the environment, especially given that plastics, in particular, take thousands of years to decay. By some estimates, plastic is killing more than 100,000 sea turtles and birds per year, whether it's because these creatures ingest them or become entangled in them. Meanwhile, the chemicals from plastics contaminate fish and enter the food chain, which means they can be passed from one species to another and affect human health too. As the Environmental Protection Agency notes, wildlife also can act as sentinels for human health. Abnormalities or declines detected in wildlife populations can sound an early warning bell for people. But it's not just about us, because the health and vibrancy of other species matter, to them and to the health and integrity of the planet in general. The difference is, other species haven't chosen to bring these chemicals into their lives and their habitats. Humans have done it for them, which means they've been innocent victims of humans' reckless and feckless behavior. As you've heard, even when specific chemicals are banned, they can persist in the environment for years, where they can harm other creatures. These persistent chemicals include heavy metals such as lead and mercury, as well as arsenic, PCBs, DDT, dioxin, and others, all of which are known or suspected endocrine-disrupting chemicals, EDCs. And as is the case for humans, other species are often simultaneously exposed to numerous EDCs, which creates the potential for harmful additive effects. But it's not just a 1+1 proposition. These effects can interact in ways that make the combination, or the whole effect, even worse than the sum of the separate parts. After all, phthalates are in plastics, PVC pipes, home furnishings, and personal care products. Phenols are in antiseptics, disinfectants, and medical products, among others, while perfluorooctanoic acid, PFOA, is in carpets, fabric protectors, stain repellents, and Teflon pots and pans. This continuous exposure may be why these non-persistent chemicals can easily be measured in urine and have been found in a majority of people in Western populations. While other species don't use these products, they are exposed to them through byproducts formed during chemical manufacturing and combustion, global transport of these chemicals through ocean and air currents, electronics recycling and garbage, and other processes. As the use of some persistent organic pollutants has decreased, the use of non-persistent compounds has increased. Yet, both classes still pose risks to reproductive organ development and can cause adverse neurological, endocrine, genetic, and systemic effects in humans and other species. Body burdens in animals. Unfortunately, these ubiquitous environmental chemicals have taken a toll on the animal kingdom in many different ways. A recent study found that 88% of biopsies from bottlenose dolphins from the northern Adriatic Sea had PCB concentrations above the toxicity threshold for physiological effects in marine mammals, and 66% had concentrations above the threshold for reproductive impairment. Meanwhile, exposure to organochlorine pesticides, PCBs, and brominated flame retardants had an adverse impact on the reproductive function of Baltic gray seals, including a high incidence of uterine fibroids in females, and led to marked declines in their population. Male polar bears in East Greenland with high fat tissue concentrations of persistent organic pollutants, including organochlorine pesticides and PCBs, were found to have reduced testosterone levels, unusually short penises, and smaller than normal testicles. There's even a disorder called imposex, which causes female sea snails to develop male sex organs such as a penis and vas deferens. The cause? Exposure to certain marine pollutants, particularly tributyltin, TBT, a highly toxic chemical that had been used extensively to prevent the growth of marine organisms on the hulls of large ships. The point is, the effects of the chemicals we have unleashed into the world are vast and far-reaching, endangering the reproductive health of numerous species and possibly their very survival. Case in point, in a series of studies, University of California, Berkeley developmental endocrinologist Tyrone Hayes, PhD, investigated the effects of atrazine, an herbicide that's used primarily on corn, soybeans, and other crops in the Midwest and around the world, on the sexual development of wild leopard frogs. He found that exposure to atrazine had a feminizing effect on male frogs, leading to gonad abnormalities such as the presence of eggs in their testicles and testosterone levels that are lower than in normal female frogs. Toads have been found to have similarly dysfunctional reproductive responses to various EDCs. Given these reproductive abnormalities, is it any wonder that frogs and toads are undergoing a precipitous population decline throughout the world? One of the most dramatic and widely reported examples of this kind of chemical impact on wildlife came from Central Florida. For many years, Lake Apopka, one of the largest freshwater lakes in Florida at 12,500 hectares, was among the most contaminated lakes in the state. This was due to pesticide use in agricultural activities around the lake, a nearby sewage treatment facility, and a 1980 major pesticide spill of a mixture of dicofol, DDT and its metabolites, and sulfuric acid from the former Tower Chemical Company, which was adjacent to the lake. These pesticides can act as estrogens, binding to and activating estrogen receptors and inducing cellular growth that's estrogen dependent. In the 1990s, University of Florida wildlife biologist Lou Guillette Jr., PhD, and his colleagues compared the reproductive development in juvenile alligators from Lake Apopka and those from a clean control lake, Lake Woodruff, in central Florida. Going out on the lakes at night in teams and airboats, the researchers would catch baby gators and take various body or body fluid measurements. Or they would collect eggs from nests during the day. They found that at 6 months of age, baby female alligators from Lake Apopka had blood estrogen levels that were nearly twice that of the female alligators from uncontaminated Lake Woodruff. And it was clearly not because the female alligators were taking estrogen of their own volition. The Apopka female alligators also had altered reproductive tract development, including more abnormalities in their eggs and ovarian follicles, similar to what happens with PCOS in human females. It wasn't just the females who were having reproductive troubles. The young male alligators from Lake Apopka had their own set of problems, particularly abnormally small penises and poorly organized seminiferous tubules, where sperm cells germinate and mature before being transported, in the testicles. What's more, the Lake Apopka male alligators had significantly lower testosterone concentrations, levels that were 3 times lower than those of the male alligators from Lake Woodruff, and comparable to those of the female alligators from Lake Woodruff. Not surprisingly, these abnormalities had the potential to significantly thwart normal sexual maturation and the alligators' prospects of successfully reproducing. Even in the wild on Lake Apopka, the hatching success rate of alligators was only 5%, compared to the 85% success rate it should be in a less contaminated lake. These discoveries were disturbing in their own right, but they also provided telling insights about the risks of human exposures. Alligators have a similar lifespan to that of humans and can also reproduce for decades. So these researchers were able to learn about the effects of pollutants on reproduction that could be relevant to humans, even though we don't literally swim in a toxic soup. But such adverse effects from exposures to chemicals are hardly limited to creatures residing in bodies of water. On land, Florida panthers that were exposed to high concentrations of DDE, mercury, and PCBs were found to have lower sperm density, motility, and semen volume, and higher numbers of abnormally shaped sperm compared to other panther populations. In Canada, researchers obtained 161 mink carcasses from commercial trappers in the provinces of British Columbia and Ontario between 1998 and 2006 so that they could examine the effects of EDCs, including organochlorine pesticides, PCBs, and polybrominated diphenyl ethers, PBDEs, on the male's reproductive development. The researchers found a significant relationship between DDE levels in the livers of adult mink and their penis length and size, most likely because DDE is antiandrogenic. Furry creatures were just as likely to suffer the reproductive fallout from these chemicals as those with scales. The dramatic fall of insects and birds. In recent years, we've been hearing dire warnings about what's being called an insect apocalypse. A 2017 study from Germany found that the country's nature reserves had experienced a 75% decline in flying insects over the previous 27 years. In coastal areas of California, the population of western monarch butterflies plunged by 86% from 2017 to 2018. In Puerto Rico, the abundance of arthropods, including insects that have exoskeletons, such as beetles, as well as spiders and centipedes, has been declining at a disturbing rate, and so have the populations of the lizards, frogs, and birds that eat them. Whether or not you appreciate insects or fear them, the simple reality is, we cannot survive without insects. As the American biologist, naturalist, and author E.O. Wilson famously noted, "If all mankind were to disappear, the world would regenerate back to the rich state of equilibrium that existed 10,000 years ago. If insects were to vanish, the environment would collapse into chaos." Insects pollinate plants and trees and provide food for birds and other animals. Cows couldn't survive without grass, and grass wouldn't exist if beneficial insects didn't provide a natural form of pest control for those insects that damage grass and help with the breakdown of organic matter so nutrients can be returned to the soil. Some species of fish wouldn't exist if they didn't have insects to eat. And chickens depend on insect-pollinated plants for the seeds and nuts they feed on. Insects are an integral part of the circle of life. Among the suspected reasons for the demise of various insect populations, climate change and the widespread use of herbicides and pesticides. The global decline in the populations and diversity of insects has the potential for significant ripple effects on food webs, the interconnected food chains within an ecological community, and hence the survival of various ecosystems. Since 1970, North America has lost nearly 3 billion birds, a 29% reduction across hundreds of species from warblers and finches to swallows and sparrows, according to a 2019 study. This is a crisis because birds also are a critical part of both the natural food chain and the planet's ecological integrity. While the degradation of high-quality habitats is the single greatest cause of the bird declines, according to Michael Parr, president of the American Bird Conservancy, pesticides are a contributing factor. Since DDT was banned or phased out, another pernicious generation of pesticides called neonicotinoids has been introduced. As Parr wrote in a September 2019 opinion piece in The Washington Post, neonics are used to inoculate plants against insects. They remove both harmful and beneficial insects. If you use 1 billion pounds of insect poison annually, as we do on the American landscape, you are going to wind up with fewer and fewer insects, then fewer birds. This is already happening off the northwest coast of Iceland, where things are uncharacteristically quiet these days. In recent years, colonies of puffins, kittiwakes, terns, and other bird species have been dying off or disappearing, and so have their chipper choruses. The numbers of penguin-like thick-billed murres dropped 7% per year between 2005 and 2008, while the populations of common murres and Atlantic puffins decreased considerably between 1999 and 2005, according to a 2016 report from the UN. It's not just that they're dying off at a faster rate. They're not reproducing at the rate they once did either. A major reason for this unfortunate demise? Our high-carbon lifestyles are turning up the ocean's temperatures, changing their chemistry, pollution loads, and food webs, and jeopardizing the health of various forms of marine life. Levels of forever chemicals such as PCBs and brominated flame retardants are taking a toll on these populations as well. The plight of these seabirds is sounding a warning bell throughout the world that more patterns like this are likely to be seen in the future. Once again, we humans created these fatal and fertility-altering effects. Hijacking the mating game. Meanwhile, some environmental contaminants have been found to alter the mating and reproductive behavior of certain species. We've seen alterations in courtship and pairing behavior in white ibises that were exposed to methylmercury, the most toxic form of mercury, in Florida. One study found a significant increase in homosexuality in male ibises that were exposed to methylmercury, a result the researchers attribute to a demasculinizing pattern of estrogen and testosterone expression in the males. Sexual behavior in birds, as in humans, is strongly influenced by circulating levels of steroid hormones, including testosterone. We are also seeing changes in reproductive behavior among female freshwater fish that are exposed to androgenic endocrine-disrupting chemicals. Simply put, these female fish spend less time associating with their male counterparts. In other instances, both sexes can have their sexual behavior hijacked by environmental exposure to EDC chemicals. A case in point, trenbolone acetate is an anabolic steroid, similar in action to testosterone, that is widely used in some parts of the world to increase muscle mass in livestock. It used to be popular in the bodybuilding community, but it has been banned from human use. Unfortunately, several metabolites of trenbolone acetate have been found in aquatic systems that are near animal feedlots. Researchers have found that fish that are exposed to even low concentrations of this androgenic chemical can experience disruptions to their reproductive development and function. In particular, female fish become masculinized during their early development, and adult females can experience detrimental effects on their fertility. In another wrinkle, a study from Australia found that short-term exposure to trenbolone altered the courtship and sexual behavior of male guppies, as well as the female guppy's receptivity to the male's sexual advances. Other dangers in the water. In the Western world, people expect their drinking water to be safe, which is why the 2016 lead contamination water crisis in Flint, Michigan, and the more recent one in Newark, New Jersey, elicited such strong public and political outrage. But an often overlooked reality is that, in addition to the possible presence of toxic metals, pharmaceutical drugs, including oral contraceptives and other hormones, may be lurking in our water supply, as well as in waterways that are home to fish and other creatures. Regrettably, the chemicals in these drugs end up in waterways after being excreted from the human body or when unused medications are flushed down the toilet. These drugs can also enter our waterways through manufacturing waste, animal excretion, runoff from animal feeding operations, or leaching from municipal landfills, according to a report from the Natural Resources Defense Council, NRDC. What's more, medications excreted in human urine, feces, and bathwater can migrate from sewers into oceans, rivers, lakes, and streams, where they can harm various forms of wildlife. As a result, it's hardly surprising that drug-polluted waterways are now home to a variety of intersex fish, namely, males that produce eggs. Or that fish and shrimp living in water that contains traces of antidepressants show alterations in their normal behavior, such as staying at the water's surface or swimming toward light, either of which can make them vulnerable to predators. Meanwhile, fathead minnows that have been exposed to antidepressants and anticonvulsants in water have exhibited neurological changes, some of which resemble autism-like disorders. Facing the messes we've made. This should give you a pretty clear picture of what's going on and what's going wrong with other species throughout the world. When the chemicals that we humans have created seep into the environment, they can take a toll on the health, development, behavior, and even survival of other creatures. The bottom line? We're essentially dosing the entire planet when we take these drugs or dispose of them improperly. Other creatures didn't sign up for this. Making matters worse, the chemicals that are altering our reproductive development and function, as well as that of the alligators, frogs, and other species, are largely coming from industries that are damaging our climate as well. As a panel of 100 endocrine disruption and climate change scientists wrote in a 2016 commentary in Le Monde, many of the actions needed to reduce the burden of endocrine disruptors will also help in the fight against climate change. Most man-made chemicals are derived from fossil fuel byproducts manufactured by the petrochemical industry. These chemicals compromise male reproductive health and contribute to cancer risks. Already, there is concern that exposure to EDCs may hinder the ability of other species to adapt to environmental changes that are driven by climate change, given that EDCs alter hormonal programming and function. As Norwegian scientist Bjorn Monroe Jensen, who studies how environmental pollutants affect animals, wrote, "When taking into consideration the long-range transport of EDCs into the Arctic ecosystem, the combination of EDCs and climate change may be a worst-case scenario for Arctic mammals and seabirds." In the past, the presence of chemicals in the environment was regulated primarily on the basis of what causes cancer, but the levels that threaten reproductive health are usually lower. This means that regulating chemicals on the basis of cancer risk can miss significant reproductive risks. For example, when the U.S. EPA analyzed fish tissue from 540 river sites across the country, the screening value for non-cancer endpoints, including reproduction, was 4 times higher than that for cancer. The concentration of 21 PCBs was found to exceed the level considered to pose an increased risk of cancer in humans in 48% of the samples. This likely means that the thresholds for reproductive damage have already been met. Findings like this suggest that it's time for a new set of regulatory standards, ones that will protect reproductive development and function for all living creatures. Ultimately, whether it's through our lifestyles or the chemical contaminants we have developed and unleashed, we're imperiling the world in which we live. Where the effects will stop is unknowable, unless we take crucial steps to reverse the exposures to chemicals in our midst and the burdens these chemicals are having on other living creatures. While it's true that environmentally induced reproductive disorders in other species are important sentinels for men's and women's reproductive health, the sexual development and functionality of other species matter in their own right. This isn't an us or them proposition. We're all surrounded by the same toxic stew. There's simply no place on the planet that's safe from these chemicals. We created these problems, albeit unwittingly, so it's up to us to come up with the solutions, as you'll see in subsequent chapters. Although limited so far, government actions to ban or restrict the use of potentially harmful chemicals in order to reduce exposure to them have already contributed to decreases in the frequency of certain disorders in wildlife, as the 2012 WHO report acknowledged. For example, after a decline in the environmental concentrations of PCBs and organochlorine pesticides, the populations of Baltic Sea seals, which had previously had a high incidence of fibroids associated with exposure to these chemicals, has been rebounding. Since TBT was banned in 2008 from use in marine anti-fouling paints, the populations of marine gastropods have been recovering throughout the world, and in 2017, no signs of ambiguous genitalia were found among sea snails in any of the monitoring stations along the Norwegian coastline. These are important examples of how cleaning up the environment can remove threats to reproductive development. Unlike other species, we, as human beings, have the choice and the ability to take steps to reverse these harmful influences. Altering this downward trajectory is likely to require drastic changes in our collective lifestyle and our regulatory processes for chemicals, pharmaceuticals, and consumer products. The challenge may seem akin to turning around the Titanic, but it can be done, and it's worth the effort, because the health, vitality, and longevity of the human race, other species, and the planet depend on it. 10. Imminent social insecurities, demographic deviations, and the unraveling of cultural institutions. Replacement values. When people hear about the precipitous decline in sperm counts that has taken place in Western countries, some shrug it off and say, well, the world is overpopulated. Fewer kids is a good thing. But that's not necessarily true. Western cultures are experiencing a demographic shift. Their populations are aging, and with birth rates dropping, these countries are not replacing their populations. This is even more true during the age of COVID-19. It would require couples to have an average of 2.1 babies to sustain a country's population through new births alone. But in most Western and in some Eastern countries, that benchmark isn't being achieved. In the United States, for example, the fertility rate, which is defined as the average number of children born per woman, was 1.8 in 2017, a 50% drop from 1960, according to data from the World Bank. In 2018, the United States had the lowest number of births in 32 years. In Canada, the fertility rate dropped from 3.8 in 1960 to 1.5 in 2017. In Italy and Spain, the fertility rate is now down to 1.3. In Hong Kong, it has plummeted from 5.0 in 1960 to 1.1 in 2017, while in South Korea it has dropped from 6.1 in 1960 to 1.1 in 2017. And the number of babies born in 2019 in China fell to its lowest point since 1961, triggering what's being called a looming demographic crisis. A major analysis from the Global Burden of Disease study corroborates these worldwide findings. Using fertility data from 195 countries and territories, after accounting for mortality and migration rates, the researchers found that the total fertility rate decreased in all the countries included in the study and declined globally by 49% between 1950 and 2017. If you're suffering from stat overload, sorry about that, but I want you to have a sense of the scope and magnitude of these shifts. This is a sea change. For many years, the world's population seemed to be rising at a steady clip. If the world's average fertility rate in 1970 had remained consistent and still held true today, the global population would be 14 billion, or nearly double what it is currently. But things didn't play out that way. While the decline in sperm counts in Western countries has undoubtedly played a role in this decreasing fertility rate, other factors are influencing these shifts too. In the United States and many other countries, men and women are waiting longer to get married, and they're having their first child at an older age, which leads to smaller families. Once people start having fewer children, they're unlikely to stop because they may discover that having fewer offspring is easier to manage and more affordable. A leading cause of this downward fertility trend, according to a 2018 report on global fertility rates, reflects the increase in women's choices, which have grown exponentially in some parts of the world. In particular, increases in women's education levels and women's reproductive rights, which include the availability of contraceptive methods around the globe, are driving the declining birth rate. The correlation between a young woman's educational opportunities and the number of children she's likely to have is clear throughout the world, but it is particularly noteworthy in countries where historically girls didn't have the same educational opportunities as boys. A 2015 study by researchers from the Harvard School of Public Health examined the effects of schooling on teenage fertility in Ethiopia, based on education reform policies that were introduced in 1994. The researchers found that each additional year of school led to a 6% reduction in the probability of teenage marriage and teenage childbearing. Similar relationships have been found between increases in female education and lower rates of early childbearing in Indonesia, as well as in Nigeria, Ghana, Kenya, and other countries in sub-Saharan Africa, where, historically, the gender gaps in secondary school enrollment between boys and girls have been sizable. What's more, between 1950 and 2016, dramatic declines in the birth rate that occurred in the Republic of Korea and Singapore coincided with heavy investments in education for girls, efforts to increase women's participation in the workforce, and high rates of urbanization. Indeed, urbanization has been acknowledged as a significant factor in the fertility decline of recent decades. Between 2011 and 2015, women living in rural areas in the United States were 32% more likely to have had 3 or more births than women in urban areas. This may be partly because in rural areas, children are often viewed as valuable commodities, as part of the free labor force that can work in the fields, feed the cows or horses, collect eggs, or handle other essential chores. In cities, by contrast, kids, beloved as they are, become more of a financial burden than an asset, another body to feed, clothe, educate, and rear, all of which is generally more expensive in a city or suburban environment than in rural areas. Given that between 2000 and 2016, the share of people living in urban areas in the United States has remained steady, while the proportion has increased in suburban and small metropolitan areas and decreased in rural areas, it's not surprising that the nation's fertility rate has been declining. Global population ups and downs. Despite the downturn in birth rates in the Western world, a large swath of the world still has fertility rates above replacement levels. In Chad, it's 5.8. In the Congo and Mali, it's 6.0. And in Somalia, it's 6.2. So while the fertility rate is declining in some parts of the world, it's still high in other regions, particularly certain African countries, which is why the world's population is currently increasing. Nevertheless, the planet's population growth isn't likely to continue the way demographers once predicted. The United Nations Population Division has developed various scenarios, based on statistical models, to project the growth trajectories of the world population. Of particular interest are 3 scenarios called the high, medium, and low variants, or growth forecasts. The medium variant, which many demographers consider to be most likely to play out over the rest of the country, is the middle-of-the-road scenario. In 2019, the UN's medium variant estimated a world population in 2100 of approximately 11 billion. By contrast, the high variant projection is based on a higher forecasted birth rate than the medium variant, while the low variant prediction reflects birth rates that are lower. Under the high variant scenario, the world's population would be 15.5 billion in 2100, nearly double what it is today. The low variant predicts a worldwide fertility rise and fall, in which the global population will peak at 8.5 billion in 2050 and then, surprisingly, decline to around 7 billion at the end of the century. While the medium variant scenario is widely quoted, some demographers and population experts disagree with this projection. Jørgen Randers, Ph.D., a Norwegian academic who co-authored the 1972 book The Limits to Growth, once warned of a potential global catastrophe caused by overpopulation. He has since changed his mind. In a 2014 TEDx talk, he stated, "The world population will never reach 9 billion people. It will peak at 8 billion in 2040 and then decline." Randers believes the primary driver of this decline will be that the world's women will choose to have fewer children than in the past. Other experts echo his beliefs. For example, a 2013 Deutsche Bank report suggested that the planet's population will peak at 8.7 billion in 2055 and then fall to 8 billion by 2100. Demographer Wolfgang Lutz, Ph.D., founding director of the Wittgenstein Center for Demography and Global Human Capital in Vienna, Austria, believes that populations that are experiencing low fertility rates are caught in some kind of low fertility trap. The gist of his hypothesis is that once fertility has fallen below certain levels and stayed there for a certain time, it might be very difficult, if not impossible, to reverse such a regime change. This hypothesis is based on 3 independent elements. As a society experiences a drop in fertility rate below replacement level, there will be fewer women of childbearing age, which means the number of subsequent births will decline. New generations embrace a smaller ideal family size, based in part on the lower fertility they see with previous cohorts, which creates sociological reinforcement. And third, assuming that the aspirations of young adults are on an upward trajectory, their expected income isn't likely to parallel this rise, which makes the prospect of having fewer children feel more realistic. In Lutz's view, these three factors will contribute toward a downward spiral in the number of future births. In some ways, age is more than just a number. The demographic picture for the United States and the rest of the world today looks quite different from the way it has in recent decades, and this trend is expected to continue. Growth from 1950 to 2010 was rapid. The global population nearly tripled, and the U.S. population doubled, as a 2014 Pew Research Center report noted. However, population growth from 2010 to 2050 is projected to be significantly slower and is expected to tilt strongly to the oldest age groups, both globally and in the U.S. We are already seeing sizable shifts in this direction. In 1960, 5% of the world's population was 65 and older. In 2018, that proportion rose to 9%, according to the World Bank. Similarly, 9% of the U.S. population was 65 and older in 1960. In 2018, the proportion rose to 16%. And in the 28 countries that make up the European Union, 10% of the population was over 65 in 1960, while in 2018, that figure rose to 20%. Everywhere in the world, the over 65 population has nearly doubled from what it was in 1960. As the birth rate declines and life expectancy increases, the population of elderly people continues to grow throughout the world. Life expectancy in the United States is now 79 years, up from 70 in 1960. In Japan and Switzerland, it's now 84, compared to 68 and 71, respectively, in 1960. Admittedly, these increases in life expectancy are one of the great achievements of the 20th century. But the declining birth rate is not. That shift is the opposite of what was happening a century ago when sperm counts and fertility rates were high and lifespans were considerably shorter. This is where the aforementioned demographic time bomb comes in. Population experts and scientists fear that future generations will struggle to meet the needs of an ever-increasing number of older adults and retired workers and their pensions/Social Security obligations. Regarding countries where the fertility rate has dropped, particularly in North America, Asia, and Europe, the United Nations Population Fund's report State of World Population 2018 noted, with larger groups of older people and a shrinking labor force, these countries face potentially weaker economies in the near term. In most developed areas of the world, the proportion of older adults already exceeds that of children, and by 2050, 1 in 6 people in the world will be over age 65, an increase from 1 in 11 in 2019. There will be far fewer people of working age to support those who are over 65. As the population ages, the ratio of older adults to working age adults, defined as those 20 to 64, is projected to rise. In the United States, for example, in 2020, there are about 3.5 working age adults for every adult of retirement age. By 2060, that proportion is expected to shrink to 2.5. Since economically active people pay considerably more in income tax and other taxes, while economically inactive people, such as children and older adults, tend to be bigger recipients of government spending in public education, health care, and pensions, an increase in the dependency ratio would cause fiscal problems for the government of that country. The potential impacts of these shifts are beyond huge, says Daryl Bricker, Ph.D. a demographic commentator and co-author of Empty Planet: The Shock of Global Population Decline. There are questions about how to support an aging population and a need to rethink all aspects of how public money is spent on pensions, healthcare, city infrastructure, schools, the military. Those are young people's games. What happens when there aren't enough young people? Who's going to pay for retirement? When you have a consumption-based economy, what happens when your population is old and the wealth resides with the older generation? These shifts have many potential consequences for societies. These include reductions in economic growth, decreasing tax revenue, greater use of Social Security with fewer contributors, and increasing health care and other demands prompted by an aging population, according to the 2017 Global Burden of Disease study. In the United States, a doubling in the number of adults over 65, which is expected by 2060, could lead to more than a 50% increase in the number of older adults requiring nursing home care by 2030, according to the Population Reference Bureau. How we manage these changes will have significant implications not only on the economy, but also on our culture, politics, and nearly every aspect of society. In the United States, these changes could lead to an epic crisis for Medicare and Social Security, warns Daniel Perrin, a nationally known policy leader and lobbyist on healthcare, public debt, and senior issues. After all, both programs are financed through taxes that are tied to workers' earnings. A decline in the working-age population could drain the financial reservoirs of these resources. Yet, Perrin says, many people aren't aware of these demographic shifts, and those that do know about this have a hard time wrapping their minds around it. They have a hard time squaring this with human history. As a result, policymakers in the United States are unprepared for these population shifts and the economic and social support challenges that are sneaking in along with them. For the year 2091, the Social Security Administration predicts that expenditures will exceed income by at least 4.48% and possibly increase to 5.97% if fertility rates stay low. It doesn't take a math whiz to see how that's problematic for the sustainability of this social support institution. Research suggests that a country's peak potential for economic growth occurs when the proportion of the population that is of working age, 15 to 64, is larger than the proportion that is of non-working age. Such a country is said to reap a demographic dividend. This is true throughout the world, but changes are afoot on this front too. Since the 1960s, the proportion of the population that's of working age increased in high-income countries, crossed the significant 65% threshold in the late 1970s, then remained relatively steady for the next 2 decades. Things started to change in 2005 as the proportion of working-age people began to decline in these countries, and as of 2017, in 12 of 34 high-income countries throughout the world, the proportion of the population of working age is less than 65%. That's problematic on many levels. Shifts such as these can have profound implications for the economic vibrancy, as well as the cultural and social conditions of a particular region. In these countries, changes in the proportion of working-age adults to older adults could have such a significant effect on economic productivity that it will likely lead to later retirement, well after age 65, which is already occurring in the United States, Australia, and Japan. These changes mean that by the time you're over 65, you may not be able to draw Social Security payments or Medicare or have access to the health care you need if there aren't enough people to provide it. Notably, Japan's proportion of the population that's of working age has dropped to less than 60%. In Japan, the 65-plus proportion of the population was 6% of the total in 1960 and surged to a whopping 27% in 2018. These days, There aren't enough healthcare workers to care for the elderly population, and restrictive immigration laws aren't helping. Meanwhile, the birth rate is down to 1.4, sperm counts are low, and fewer males are being born compared to females, as often happens in response to environmental stressors. At the same time, more women of childbearing age are putting their careers first and postponing or rejecting marriage and motherhood. The Japanese culture places such a premium on professional success and long work hours that many people of reproductive age reportedly aren't even interested in having sex, according to multiple sources. This has supposedly given rise to celibacy syndrome, Sekusu Shinai Shokogun, which has been described as a decline in sexual interest and activity or even romantic relationships among young adults in Japan. The reasons for this sexual slump aren't well understood. As an article in The Independent noted in 2017, the fertility crisis has left politicians in Japan scratching their heads as to why youngsters are not having more sex. Naturally, there are theories, ranging from the enduring social values of modesty and purity in Japan, which make the prospect of casual sex difficult to navigate, to young Japanese men's and women's changing life desires. For example, being more dedicated to careers, not wanting to have traditional relationships, and showing an increased interest in online pornography. Whether hormonal factors or dietary influences play a role is a matter of conjecture, but some evidence suggests that testosterone is lower among Asian people and that greater consumption of soy foods, which are rich in estrogenic compounds, may have a libido-compromising effect in men. It may be that in Japan, a perfect storm of physiological, cultural, dietary, and environmental influences is leading to a loss of that loving feeling, not just lower sexual frequency, but also lower sexual satisfaction. Interestingly, this conscious or unconscious uncoupling, along with the so-called epidemic of loneliness that's been identified in the country, has spawned some new social inventions to help people feel less alone. In Japan, anyone who wants to have a child without actually having one can buy a toy-sized robot companion that has the mental acuity of a fifth grader. For $3,000 or more, men can purchase lifelike anatomical female sex dolls for companionship. It's not unusual to see men taking these dolls for walks in wheelchairs in public. The Japanese artist Tsukimi Ayano has been crafting mannequins and positioning them throughout the tiny village of Nagoro in southern Japan in an effort to make the place feel more populated as people move away or die. Recently, an industry has sprung up that allows lonely people to rent family members, actors who play the roles of spouses, parents, children, or grandchildren, for temporary companionship. One of the hazards of the occupation? Client dependency. Sometimes clients just don't want to say goodbye to these rented relatives. A salon owner in San Francisco, Shiori, 43, was raised in Japan and came to the United States in 2001. Married with 2 children, she and her family travel to Japan every few years to visit relatives, including Shiori's younger sister, who is single and doesn't want to have children. While visiting Japan in August 2019, Shiori was struck by the sense that people are lonely. Country schools have been reduced to one-room schoolhouses because there are so few children. Instead of dating, young adults prefer to relax by going to a manga cafe or an internet cafe. The population of Japan has been shrinking steadily since the 1970s. By 2065, it is expected to drop to about 88 million, compared to 126.5 million in 2018. With fewer babies being born and a growing elderly population, Japan is facing the prospect of an unparalleled demographic crisis that could have significant ripple effects socially, economically, and politically. To try to avert this looming crisis, some local governments in Japan have been offering cash incentives to encourage young women to get busy having babies. While some evidence suggests that this approach has spurred a slight uptick in the fertility rate in certain areas, whether it will last remains to be seen. The situation in Singapore is equally disturbing. The most recent figures put the total fertility rate at 1.1. In 2018, the personal lives of Singapore citizens were examined in detail in the country's parliament, as members wrung their hands over the country's low birth rate and wondered why government schemes to encourage parenthood hadn't produced more results. A minister said Singapore's total fertility rate had fallen below replacement levels for some 40 years, noting that these same trends have played out in developed East Asian societies such as Japan and South Korea. The parliament recognized that financial and legislative measures alone aren't enough to turn things around. When a popular online publication solicited ideas from readers for ways to improve Singapore's birth rate, all the suggestions related to improving social support, financial incentives, access to childcare, and free fertility checks, and encouraging Singaporeans to have more sex, which surveys suggest they aren't doing on their own. One 32-year-old man suggested the parliament should start a campaign to make it fashionable to have sex. Another suggestion, the best role for women is at home, which suggests that one backlash to low fertility rates, at least in Singapore, is to try to keep women out of the workplace and have them stay home to raise children instead. What's happening in Singapore and Japan provides a cautionary glimpse into the future for the United States and other countries that have declining fertility rates. So far, Japan and Singapore have been unable to turn their birth rates and population declines around. In the United States, we're on the same trajectory, and we may end up facing similar challenges. Which sex is outnumbered now? Around the world, the ratio of men to women is changing too. Historically, 105 males have been born for every 100 females, which means that 51.5% of births have been male. This is called the secondary sex ratio, and this is what the World Health Organization expects the ratio of males to females to be at birth. It's considered the natural equilibrium, in other words, but this ratio isn't stable. It's influenced by biological, environmental, social, and economic factors. Why this matters? The sex ratio can change in both human and wildlife populations in response to environmental factors and personal stressors. A shift in the sex ratio, which is usually in the direction of fewer male births, can be a sensitive indicator of sudden or pervasive environmental dangers. Surprisingly, a man's exposure to these dangers is more likely to lower the chances that his child will be a son than his female partner's exposure is. As you saw in earlier chapters, while they're in the womb, males appear to be more sensitive to prenatal exposure to toxic chemicals, as well as to catastrophic events in the external world. Research has found that mothers who had the highest exposure to polychlorinated biphenyls, PCBs, from consuming contaminated fish from the Great Lakes were less likely to have a male child. And studies in Canada, Taiwan, and Italy have produced similar findings stemming from exposure to environmental toxins. Remember, despite being banned in 1979, PCBs and other persistent organic pollutants, or POPs, continue to linger in our air, water, and soil. They're forever chemicals, with the potential to do endless harm. Meanwhile, the 1995 Kobe earthquake in Japan, the 9/11 attack in New York, economic downturns, and war have all been shown to slightly lower the ratio of boys to girls that are born. In the case of the Kobe earthquake, some researchers suggest that the sex ratio changes may be due to acute stress and a reduced sperm motility. Fortunately, the effect on sperm motility is usually temporary and is typically restored to where it was within 2 to 9 months. Climate change also appears to be skewing the sex ratio. One study found that recent temperature changes, especially very hot summers and very cold winters, in Japan correspond to a lower ratio of male to female newborn infants, partly because of a dramatic increase in the proportion of male stillbirths. In particular, 9 months after a very hot summer in 2010 and 9 months after an especially cold winter in January 2011, more females were born than males. It's not only external environmental factors that can affect a male baby's chances of surviving in utero. An expectant mother's stress level can also play a role. A study from Denmark found that among 8,719 pregnant women, those who experienced high or moderate levels of psychological distress in early pregnancy were less likely to give birth to baby boys. The mothers with the highest levels of psychological stress, based on their responses to a commonly used health questionnaire, had boys 47% of the time, whereas unstressed mothers gave birth to boys 52% of the time. This discrepancy may not seem like a big deal, but it means the difference between a sex ratio of 0.85 and 1.07, a considerable gap. The researchers concluded that stress during pregnancy is a likely culprit in the decreasing sex ratio in many countries. While the biological mechanisms behind these effects aren't clear, some researchers suspect that after the 20th week of pregnancy, male fetuses may be more sensitive than female fetuses to a mother's corticosteroids, the hormones that are produced by the adrenal glands at higher levels in response to stress. This elevated stress reactivity could jeopardize the viability of males while they're in the womb. Regardless of the precise mechanisms behind these influences, given that males are especially threatened by environmental chemicals, climate change, and a mother's psychological stress, they will continue to face dangers in utero unless the world as we know it changes dramatically. The future fallout potential. All of these societal shifts should make us wonder, who's going to run the show in the future if not enough children are being born to support the world that we've built? Who will take care of our older adults? What does this mean for the fate of the human race? Whether it's because fewer males are born or women outlive men, the ratio of women to men will continue to increase as part of the demographic shift, and an older population will be composed largely of women. And if the decline in sperm levels really is occurring at a faster rate in Western countries than in developing countries, as the current data suggest, there will be socioeconomic shifts throughout the world. The world's population is in flux on multiple levels, and this much uncertainty is unnerving for the future of social support programs, economic stability, national and international planning decisions, and other factors that are fundamental to a country's ability to operate efficiently. These shifts can affect the functionality of individual countries, as well as population shifts on the global stage. In 1950, high-income regions in Central and Eastern Europe and Central Asia accounted for 35% of the world's population. In 2017, the populations in these countries constituted 20% of the world's population. Meanwhile, large population increases occurred in South Asia, Sub-Saharan Africa, Latin America and the Caribbean, North Africa, and the Middle East, as the Global Burden of Disease study found. When these trends are considered along with declining sperm counts, there's even more cause for concern. Not only are men becoming endangered, but the human race as a whole is too. Even if the will is there to reproduce and increase the birth rate, the machinery isn't as functional as it used to be for men or women. We have declining sperm counts, diminished ovarian reserves, increasing miscarriage rates, and other reproduction-related problems that can hamper success in the realm of baby-making. Some scientists are now suggesting that the detrimental effects on human reproduction and the underlying factors contributing to them could threaten the survival of the human race. It seems hard to fathom, but an argument could be made that Homo sapiens already fit the standard for an endangered species based on the U.S. Fish and Wildlife Service's FWS requirements. Of 5 possible criteria for what makes a species endangered, only one needs to be met. The current state of affairs for humans meets at least 3. The first is that we are arguably experiencing destruction, modification, or curtailment of our habitat. Our habitat includes our air, food, and water, each of which is being contaminated by pesticides, plasticizers, perfluorooctanoic acids, PFOAs, and other toxins that threaten human health and longevity. Nearly 25% of deaths worldwide, which adds up to 12.6 million